Hi and welcome back to another AnyRPG Development Livestream. In these videos, I livestream the development of the AnyRPG Engine, a 100% free and open source role-playing game engine designed in Unity and written in C#. These videos are unscripted and give you a chance to take a behind-the-scenes look at the unfiltered, methodical side of software development. For more information on AnyRPG, be sure to check out AnyRPG.org, where you can find documentation on the engine, links to the full source code at the official GitHub repository, and downloadable versions of AnyRPG Alpha, a free game designed to showcase the features of the AnyRPG engine. If you would like to see more of this type of content in the future, be sure to subscribe to the Cohesion channel, like the videos, or just leave a message in the comments telling me what you would like to see. In today's episode, we'll be continuing the cleanup of the Unity package so that we can export it. And I did a little bit of research, and as it turns out, my dreams of having a built-in shader that allows me two-sided is not going to happen. So I'm just going to use the standard shader, set it transparent, and then that way we don't have to worry about that. At some point in the future, I'll create or go find a good public domain shader that allows double-sided transparent items, but for now I just don't see that happening, unfortunately. So there were a couple of other things that we needed to do in our package before it's going to be ready to export, and one of those things was get the channeled spells working properly. Previously we only had like one type of channeled object for a spell, and that one is a third-party one that we don't own. So what I'd like to do is get something that we own, and so let's or create something that we own basically. So let's go to load game, and I'll just go demonstrate that here. We'll go down to the player name, hit load, and let's just go into the combat scene. So teleport example, combat scene. Okay, and over here, let's go find somebody. There, we got a guy, example Goblin Ranger, and I have a channeled spell. Let's find one, lightning tether, life tether. Yeah, actually that's good. See if this, right, yeah, so nothing's happening with life tether AoE, and I forgot to hit error pause here, but basically object not set to an instance of an object. So our channeled spells aren't working, and that means that we need to, I think, just create a prefab for those. So let's just go take a look. We were doing life tether AoE, and if we look at this, ability casting prefab was AnyRPG Violet Sphere. The channeled ability effects were example life tether AoE effect. And basically we have no ability effect prefab there. Let's just go look at the lightning tether AoE, the regular non-example one. So this is basically what appears on the ground while you're casting it, and if I click on the lightning tether AoE effect, okay, we do a lightning tether channel. There, and the lightning tether channel has an ability effect prefab, this simple animated lightning bolt prefab. So what we want to do is look at our example lightning tether channel. Actually, how about example life tether, because I think that was the one we were just casting there. So example life tether AOE, we go to example life tether AOE effect, which leads to example life tether channel. And we have this simple lightning bolt prefab still listed. And that's here. Actually, I'm really kind of surprised that we don't have a reference to this somewhere in our game. When we were making the packages, because I mean this looks like a reference to me. So let's see what line of the code we were on here and figure out how we got that null reference. Control AKF will fix the formatting. And basically it looks like there's no null check right here. So if lightning bolt script does not equal null, then do all that stuff. So then this actually really shouldn't even be called lightning bolt script. It should be called like channeled object script. So let's just rename that, because we do a lot more than lightning bolts. It was originally called this because the very first channeled thing that I added was a lightning bolt. So channeled object script, and then if we look at basically that thing right here, let's I guess we gotta wait for it to compile, and then we'll be able to click on it there. And then if we look at that, we see the lightning bolt script. We've got the wrong lightning bolt on there. That's why. So let's go to the interface there, and we'll click go to implementation. Okay, there we go, that's better. So we have our channeled object script, which is what we want. Okay, so the channeled object script, I wonder if I can go select dependencies. I think maybe like I know I created the script, but I don't think I actually put it on anything yet. Maybe that's what happened there. So let's see, the channeled object script here. We'll actually need like a different one for each of them, because this channeled object is kind of specific to a lightning bolt, and we want other types of channeled objects. But so what we'll have to do here, let's see, I'm just going to make a duplicate of that and then rename it to channeled cube script. You know what? What if I made it channeled cylinder script? I kind of want something round, actually. Yeah, channeled cylinder script. Okay, and we'll go into our channeled cylinder script. So the only thing it needs is basically a couple of properties. These guys right here. And we can just wipe out everything else in here, pretty much. And then we'll need to make a cylinder for that. So let's go into our examples directory and prefabs and shapes. So we've got some cylinder here. And I think, let's see, how many do we want? I think it was like 9 basically. Black, blue, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so we want 9 of them. So duplicate that. Okay. So cylinder blue, cylinder yellow, cylinder green, cylinder violet, cylinder gray, cylinder red, cylinder brown. What's the last color that I forgot here? White. That's what we need. We need a cylinder white. Okay, so we'll make a cylinder white. And then we'll set all the colors on those. So black material, blue material, brown material, gray material, green material, red material. Violet material. Oops, oh, mesh, that's why I clicked the wrong one. Yeah, let's try that again. This one is supposed to be white. Yes, white material. And yellow material. Okay, good. And then we want to make duplicates of all those and make basically transparent copies of them. So swap out everything here. And the red ones as well. And then violet transparent. White transparent. And yellow transparent. Okay, good. So then what I want to do now is, let's see, we can make a new directory here, create folder, and I'm going to call this channeled. And then basically, what I want to do is duplicate all of these transparent cylinders. Move them into channeled. And we'll call this AnyRPG. Instead of cylinder black transparent, we'll call it channel black transparent. Huh. That's not looking very transparent. Let's see why not. Standard transparent. Okay. Well, if it says so. Doesn't look transparent to me, but I guess, yeah, I guess maybe it is. Maybe it just, you can't really see that it's transparent because of the gray background. Okay, so anyway, let's go back to our prefabs directory. And channel blue transparent. Channel brown transparent. Channel gray transparent, channel green transparent, channel red transparent, channel violet transparent, channel white transparent, and channel yellow transparent. And these guys all need to get a component on them, and that's going to be the channeled cylinder script. None of them need colliders on them. Okay, good. So now they all have the channeled cylinder script on them. Now what we have to do is basically create the code that will stretch this between the start and the end object. So to do that, let's just start by it's gonna have to follow the objects. So I guess we can give it an update method, and we'll want to get the difference between the start position and the end position. But more importantly, we'll want to track the position of the objects. So the best way to do that will be, I guess, we want to get the world coordinates of the positions, and these positions are basically like offsets from the object. So we can do that by going vector 3 absolute start position equals my start object dot my start object dot transform point local space to world space my start position. So basically that should give us the world space point of whatever the start position is relative to the start object, and then we want the absolute end position, and that'll be my end object dot transform point my end position. So we need to do that basically every frame, because us or the object could be moving. So we'll need to keep this thing basically moving with it. Then what we need is a float to keep track of the, I guess we can just call it like distance vector Distance vector is a really bad word, but how about distance magnitude? Because naming something vector sort of implies that it's going to have a vector in it. So distance magnitude equals I think we can go vector3 dot distance for absolute start position and absolute end position. I'm going to make just a hard-coded private float. We want the X and Z radiuses to be 0.1f on this thing. Okay, and then what we do is now we've got everything we need to actually set the size of this, I think. So we'll want to do that by going transform.local scale equals, and this is going to be a vector 3. So vector 3 updated local scale equals new vector 3. So for the X, we want basically X radius. For the Y, because cylinders are basically on their end, we want the distance magnitude, and then for the Z, we'll want the Z radius. And then we'll set this to updated local scale. Now what we'll want to do is we'll want to transform this thing. So now we actually do need a distance vector. So vector 3 distance vector. No, whoops, that's actually a direction vector. Direction vector equals absolute start position minus absolute end position. And we need to, I think the way this is going to work basically is because of the fact that our cylinders are sort of in the center, we'll need to actually set the position of the cylinder directly in between the object, or between the two objects. So what's the best way to do this basically? So the direction vector is going to be basically our look rotation, or our transform.forward. So we just want to take those two values and normalize them. And then we want the midpoint. So I think I can do this. Midpoint equals new vector 3. I'm just experimenting here, but hopefully this works. So I think what we want to do actually is we want to go the absolute start position dot x minus the absolute in position dot x divided by 2. And we'll want to put brackets around that just to ensure that that gets done. And what 2f done in the right order, I think. So I'm not sure if like C# does order of operations and would do the division before the addition operation or not. So just being safe there. And same thing basically for the y. And same thing for the z. Now, if I didn't mess that up, that will be the midpoint between the two of them. So then we want to go transform dot position equals midpoint. And finally, we want to do the rotation. So transform dot rotate no. Can I just set transform dot rotation equals quaternion dot look rotation, and our vector 3 forward is our normalized direction vector. Okay, I don't know if that will work. Let's actually put this inside its own method. So what do I want to do? Basically, I want to track these things. So let's make a private void update I don't know what you even call that. Private void update scale and position. No, you know what? This is going to be update transform because I'm just going to call it update scale and position and rotation, and those are basically just the transform properties. So let's call it update transform. I don't think that's a used thing. So what we want to do is we don't want to be running that if nothing is changed. So we'll set an initialization variable. It's going to be false by default. Right, it's not a float, it's a boolean. Okay, and then in our update method, basically we're going to go if, you know what else we need to do? We need to set some other variables. We need a private vector 3 last start position and a private vector 3 for last in position. And then we want to do last start position equals my start object dot transform dot position, and then do the same thing for the last in position. My start object dot my end object dot transform dot position, and then we can if either object initialized equals false, or and I guess we can set these as vector 3.0. Just to make sure they have something in them. So then we want to just compare if or last start position does not equal my start object dot transform dot position, or last end position does not equal my end object dot transform dot position. Okay, so what this will do basically is if it's initialized and then nothing's moved, then we won't bother going and doing all these calculations right here. So the idea here is basically just to save ourselves like a few calculations. So then we want to do update transform. Okay, so I think that's all the code that we need. So basically what I want to do here is go back into the game or into Unity and test this out. So let's we need to go to our channeled spells. So under the example resources folder, we have channeled effects. Okay, good. So example life tether channel. Life tether, let's make it purple. So we want the channel violet transparent. And then for the lightning destruction aura channel, we want the channel blue transparent. And then for the lightning tether channel, we also want the blue channel blue transparent. Okay, and that looks pretty good. So let's save that. And we already fixed this up basically, where it's only going to do that if it actually found the channeled object component. So I think we can now go back into the game and try that out. I don't know. I think I might have to fix the orientation a little bit. Yeah, actually, come to think of it, it's probably going to be like straight up in the air above me. But we'll just go see. For now, I'd be happy if we can at least manage to spawn one of these little prefabs. Okay, so let's see. I want to see if I can actually find just a life tether or lightning tether single spell. So where are those? Ah, life tether. Okay, perfect. Life tether. Okay, well, the good news is the spellcast now works. So we got rid of that issue where it wasn't casting, but let's see here. I see this cylinder. And the default prefab lifetime is 1. Okay, let's go into the scene and just hit uncheck 2D and then hit F. Okay. So there's the cylinder and it's like way over in the wrong spot there. But that's good. You know, at least it spawned. I think it's a little long as well. So I think now let's actually put this thing into debug mode for a sec. I just want to see if there's any properties we can see on that cylinder that are going to be useful to us. The last start position and last end position there. Those look okay, I think. Let me just confirm that. The last start position, -34 and 32. And if I look at my default player UMA unit, he's at -34 and 32. So that, I believe, is correct. But okay, what's this here? Oh, right, okay, so the center of my player unit is just showing as there because of the fact that it's showing the center between these two things. Okay, so what do I want to do here? Basically, for some reason, let's actually look at the position of that. The actual position for the transform is 10 and -53. So let's go back and just look at the code there. See if we can figure out what's happening with the positions. And that should be right because it sets the world space position. For now, we'll just ignore the rotation, although I know we need to fix that because it's pointing straight upwards. And then the local scale should be okay. Maybe I've just got these backwards. Direction vector, I might have done that in the wrong order. That's for the transform dot forward. So we want that. But these might be wrong here. I feel like I have those reversed. Is it x plus y over 2? It's not x minus y over 2. Okay. Let's just try that. Okay, and let's restart. Play, load game, load this. Oops. Jump back into the combat level. I think I'm just going to save it in here. Select one of the guys, life tether. Okay, perfect. Wow, that is actually exactly how we calculate the midpoint. Perfect, and that was working, moving towards me. Oh, I actually want to select that guy. Okay. Okay, that's not bad. It looks like it's about twice as long as it needs to be. So I guess the distance magnitude, we probably want to divide that by 2. And then for the rotation, now this will turn the thing in the correct direction, but then we actually want to like rotate it. So I think in this case, this is where we want to rotate it. Let's see, 90 degrees around the x-axis. Because basically the z-axis points forward, so a rotation around the z-axis will put him to the left or the right. the y-axis points upwards, so rotation around the y-axis will just sort of like pan him left or right, and the x-axis goes through him horizontally, so we want to rotate forward 90 degrees about the x-axis, I think. So let's try that this time. Okay, and we can press play, load the game, click load. Okay, let's run over there, find somebody, zap them. Oh yeah, what is that? That is a ray going directly from the center of my character over to the guy. That is so rad. Now we finally have our own channeled spell that we own. Oh my god, it's like a laser beam. Oh, that's so rad. I make like rainbows and stuff. If you guys have ever seen like World of Warcraft, they've got like a rainbow generator that does sort of the same thing. That would be awesome to do. Okay, cool. So let's test the other ones. We got the life tether AOE. Oh yeah, just lasers and lasers. Rad. Okay, and lightning tether. Yeah, it's the blue one. So cool. And lightning tether AOE, and we are zapping the pants off of these guys. Shoo, pew pew lasers. Okay, I am more than happy with that. Um, Basically, that's all I wanted to do for this episode. I just wanted to get the prefabs for the channeled spell built. We'll keep this one short, nice little self-contained chunk of work there. So as always, you know what, actually, just before, because I've been forgetting to do this lately, and I've been going to committing this stuff afterwards, but one of the things that I really like to show in this series is the entire development process, and very important thing here, because we now have a feature we just tested, we added it, it works. So that means it's time to go ahead and commit this stuff to Git. So Git status, that's not bad. We only really had to like update 3 scripts. Okay, cool. Git add -a dot git commit, add a message, added channeled cylinder code. Added channeled cylinder code. Yeah, that's good enough. And push that, and now we have a nice little tiny commit that just tracks just the code we did for that. So in the next episode, I think it'll be time to go through and clean up the animations. If you saw at the end of our cast, our guy like sunk halfway through the ground, and that means that there's definitely something wrong with the animations. So I will go through in the next episode and just do a little bit of cleanup and fix up on those animations, and then we'll hopefully be ready to export this thing after that. As always, if you like this type of content or you'd like to see more of it in the future, subscribe to the Cohesion channel, give this video a thumbs up, or just leave a note in the comments letting me know what you'd like to see. Thanks for tuning in, and I will see you next time.